Hey there, science fans, let's talk trash. I know, not the most glamorous topic, but trust me, it's important. You might not think about it often, but the way we handle our waste has a huge impact on our environment and our daily lives. Every day we produce mountains of garbage. From the packaging of our food to the old electronics we discard, it all adds up. Imagine if we didn't have a system to manage all this waste. Our cities would be overwhelmed. This waste has to go somewhere, and that's where landfills come in. They are the unsung heroes of waste management, providing a place for our trash to be safely stored. Landfills are carefully engineered facilities designed to safely contain our trash. They are not just random holes in the ground, they are sophisticated systems built to protect our environment. They're like giant high-tech storage units for everything we throw away. Each layer and component is meticulously planned to ensure that harmful substances don't leak into the soil or water. But these aren't your grandma's dumps. Gone are the days of simple, unregulated dumping grounds. Modern landfills are a far cry from those old, unsanitary sites. Modern landfills are marvels of engineering, built with layers of protection to safeguard the environment. They include liners to prevent contamination, systems to collect and treat leachate, and even gas collection systems to capture methane for energy. From the initial site selection to the long-term monitoring systems, engineers play a vital role in ensuring that landfills operate safely and efficiently. They conduct extensive research and planning to choose the best locations and designs. They use their knowledge of geology, chemistry, and environmental science to design and manage these essential facilities. Their work doesn't stop once the landfill is built. They continuously monitor and maintain the site to prevent any potential issues. So next time you toss something in the trash, remember the hidden world of engineering that keeps our waste in check. It's a complex and fascinating process that ensures our communities stay clean and our environment stays protected. Choosing the right location for a landfill is like finding the perfect piece of real estate. It's all about location, location, location. But unlike real estate, the stakes are much higher. A poorly chosen landfill site can lead to severe environmental damage, affecting not just the immediate area, but potentially causing widespread harm. This makes the selection process incredibly meticulous and thorough. Engineers spend countless hours studying maps, analyzing soil samples, and assessing groundwater flow. They use advanced technology and tools to gather as much data as possible. This data helps them understand the geological and hydrological characteristics of the area, which are crucial for determining the site's suitability. They're looking for a site that minimizes the risk of pollution and protects the surrounding environment. This involves evaluating the potential impact on local wildlife, vegetation, and water sources. The goal is to find a balance between practicality and environmental stewardship. First and foremost, landfills can't be built just anywhere. There are strict regulations and guidelines that dictate where a landfill can and cannot be located. These rules are in place to protect public health and the environment. They need to be situated far away from residential areas, bodies of water, and sensitive ecosystems. This is to ensure that any potential contaminants do not reach these critical areas. The distance acts as a buffer zone, providing an additional layer of protection. The goal is to keep any potential impacts from reaching these important areas. Engineers design multiple layers of protection, including liners and leachate collection systems, to prevent any leakage. The ideal location will have a thick layer of clay or other impermeable soil beneath it. This natural barrier helps to contain any liquids, known as leachate, that might seep through the waste material. Think of this layer as a natural bathtub that helps contain any liquids generated within the landfill. This containment is crucial for preventing groundwater contamination, which can have far-reaching consequences. Engineers also consider factors like rainfall, flooding potential, and earthquake risk to ensure the landfill's long-term stability. These natural events can compromise the integrity of the landfill, so it's essential to choose a site that can withstand these challenges. By taking all these factors into account, engineers aim to create a landfill that is safe, efficient, and environmentally responsible. Imagine a landfill like a giant multi-layered cake, but instead of frosting and sprinkles, it has layers of engineered materials designed to keep our environment safe. This protective shell is what makes modern landfills so different from the open dumps of the past. At the bottom of the landfill lies a thick liner system. This system typically consists of multiple layers of clay and high-density polyethylene, HDPE, plastic. These materials work together to create an impermeable barrier that prevents harmful liquids from escaping into the surrounding soil and groundwater. On top of the liner system, a network of pipes is installed to collect leachate. Leachate is the liquid that forms as rainwater percolates through the waste, picking up dissolved materials along the way. This liquid is then pumped out and treated to remove any harmful pollutants. Leachate, the liquid produced within a landfill, might sound a bit icky, but it's something engineers take very seriously. This liquid is not just any ordinary water, it's a complex mixture that requires careful attention and management. The process of handling leachate is crucial to ensure that it doesn't pose a threat to our environment or public health. It's essentially a cocktail of rainwater and dissolved materials from the waste, and it needs to be carefully managed to protect our environment. When rainwater infiltrates the landfill, it percolates through the layers of waste, picking up various contaminants along the way. This mixture can become quite toxic if not properly controlled. As rainwater seeps through the layers of garbage, it dissolves various substances, creating leachate. This process is continuous and can generate significant amounts of leachate, especially in regions with high rainfall. The composition of leachate can vary greatly depending on the types of waste present in the landfill. This liquid can contain organic compounds, heavy metals and other pollutants that could contaminate groundwater if not properly contained. These pollutants can be harmful to both the environment and human health, making it essential to have effective leachate management systems in place. That's where the leachate collection system comes in. These systems are designed to capture and control the leachate, preventing it from escaping into the surrounding environment. The design and implementation of these systems are critical to the overall effectiveness of landfill management. Remember those pipes installed beneath the landfill liner? They play a vital role in the leachate collection process. These pipes are strategically placed to ensure maximum efficiency in capturing the leachate as it forms. Those pipes act like straws, drawing the leachate out of the landfill and into a series of storage tanks or treatment facilities. This system ensures that the leachate is collected and transported to a location where it can be treated safely. Once collected, the leachate undergoes a series of treatment processes to remove harmful contaminants. These treatment processes are designed to address the specific composition of the leachate, ensuring that all pollutants are effectively removed. This might involve physical, chemical, or biological methods, depending on the composition of the leachate. Physical methods might include filtration or sedimentation, while chemical treatments could involve neutralization or precipitation. Biological treatments use microorganisms to break down organic pollutants. The treated water is then safely discharged, often to a wastewater treatment plant or directly into the environment if it meets regulatory standards. This final step ensures that the water released is safe and does not pose any risk to the environment or public health.